Gwinnett Woodworkers classroom is located at the back of the retail space of Peachtree Woodworking Supply. From this space, we conduct about 70 meetings per year. Most of these are recorded for potential inclusion as a YouTube video. Peachtree provides the classroom for us under the provision that it be used solely as education delivery and not for sales presentations. Okay, today we will cover the classroom audio-visual equipment in two passes. First will be an overall view of the equipment involved. This will be followed by a second, more in-depth view of the equipment and how it works. The center point of the equipment is the camera platform. It is the first stop for the recorded video and audio. From here, the audio and video is relayed to the equipment cabinet. The equipment cabinet contains most of the electronic equipment required to control the classroom audio-visual aspect of the presentation. From here, camera selections are controlled, as is the classroom sound level. Inside are a bunch of infrastructure items that we'll cover more in depth later. Inside the cabinet, a matrix switch controls which audio-visual source is shown on which wall monitor. An overhead boom-mounted camera is used to capture the tool work of the lathe operator. This greatly enhances the audience visibility of the demonstration. Typically during a presentation, one wall monitor is showing the view from the tripod camera while the boom camera view is shown on the second wall monitor. We also use a doorway camera, which is used exclusively for the YouTube editors to give them another camera angle to choose from when needed. This camera doesn't participate in any of the switching of the wall monitors. To help the instructor see what the cameras are seeing, a pair of monitors are placed in front of the instructor's position. This helps the instructor to see that the cameras are capturing what he's trying to show. This also prevents the awkward motion of having to look behind or over his shoulder to confirm visibility. We also use a ceiling-mounted projector against a retractable projection screen to show computer-based presentations. To facilitate computer presentations, we use a cable to attach to the presenter's laptop and switch the output up to the projector. Now we will go back through the equipment to cover more deeply how it all works. We use Canon Cameras for consistency of operation and cross-training. They're consumer-grade video cameras that have no internal memory. Since we record everything to SD cards and then transfer or transport the result to a computer, internal memory on the camera is unnecessary and costly. When we need one or more new cameras, we can often find ones without memory on deep discounts at retail closeouts. We also need devices that have HDMI built in, as that's what we have standardized for connectivity in the classroom. It's an easy, reliable, and standard method to transport video. To maximize portability in the classroom, we make extensive use of wireless HDMI. So equipped, the tripod doesn't need connectivity to anything but power. From our tripod camera, we can connect the camera to a wireless HDMI transmitter. This particular unit is made by Nereus. Since the microphones on the consumer-grade cameras are usually on the low end of quality, we use an on-camera shotgun microphone to pick up sound close to the camera. We also make use of wireless microphones to capture as good a quality sound as possible. We mic up the presenters with lavalier mics to capture the best quality sound. Again, we standardized on Sennheiser as a high-quality brand of consistency of operation and cross-training. A recently added device to the camera platform is the wireless audio transmitter. After considerable study, we determined that the latency of transferring audio through the wireless HDMI was causing considerable echo in the classroom. The delay of the audio through the wireless system was in excess of 100 milliseconds due to the encryption, de-encryption that was going on inside due to the HDMI standards. We solved it by putting the audio through the wireless system intended for stage use that would have no discernible latency. At the equipment cabinet, all the various inputs and outputs converge. The heart of the equipment is a 4x4 matrix switch made by Octava. It enables us to hook up 4 different input devices and 4 different outputs and switch between them at will. The only drawback is the handshake time that HDMI imposes for reestablishing a new connection. The wireless devices converge at this cabinet and connect to the matrix switch. When we found a need to add another wireless HDMI pair, we discovered that another of the same brand was not possible. The devices are made to plug and play for the consumer. With that as a goal, they don't have the capability to be configured or paired by a user-assigned address. Our solution was to pick out different brands of HDMI equipment in hopes that they would use different frequencies. So far, this has worked. The HDMI from the computers goes through an Octava-provided splitter that picks off the audio component of the data stream to connect to the Behringer-powered mixer. This enables us to put high-quality audio from the classroom computer or a laptop out to the classroom speakers. Bose speakers were chosen for the 4 corners of the classroom in order to provide the highest quality sound possible from a small package. A single output from the Behringer amp feeds a speaker controller that allows us to fine-tune the output of each speaker for the classroom acoustics. On top of the cabinet is the receiver for the overhead boom camera and the transmitter for the instructor monitor. The instructor monitor is on a separate channel of the matrix switch to enable it to display whichever camera the instructor needs to see to prevent him from having to repeatedly look at the monitor behind him. The instructor monitor is an LCD display from a computer. It's mounted to the lower mast of a microphone stand. The stand is typically placed a few feet in front of the instructor's home location. The stand includes a multi-outlet strip for power for the monitor and the wireless receiver. It also provides a location to plug the power cord from the tripod if appropriate. This display is very helpful when the instructor needs to hold something small so the camera can zoom in on it. The instructor then has visual confirmation of the success of the shot. The camera operator can also use the monitor to augment the tiny display on the tripod camera. Adjacent to the instructor monitor is the boom camera monitor that is again an LCD display from a computer. Again, it's mounted to the lower mast of a microphone stand. The stand is typically placed within the field of view of the instructor and the operator controlling the boom camera. The boom camera is another Canon consumer-grade camera. It's mounted to a tripod head on the end of a piece of square aluminum tube from a local metal supplier. The metal boom is mounted to a shop-fabricated bracket atop a hospital IV stand. The HDMI transmitter to the equipment cabinet is affixed to one side of the bracket. The classroom monitors are attached to the wall and have HDMI cables back to the matrix switch channels 1 and 2. These are 40-inch Vizio models that have the audio fully turned down to prevent feedback. A recent addition to the classroom is this overhead projector. It's an Optima HD26. It's a highly rated 3200 lumen business class projector. We typically only have to shut out the first row of lights to give great visibility from anywhere in the classroom. We coupled this with a electric retractable projection screen by daylight. Both have worked flawlessly since installation. The projector plugs into one of the channels of the matrix switch to permit any of the computers or cameras to project onto the screen. At the conclusion of a video shoot, the SD cards from the various cameras are collected. A script is run on the computer to copy all the necessary files from the cards onto large hard drives on the computer. Once that process is complete, the generated folders from that operation are copied onto thumb drives to distribute to one of the video editors. Most of the editors use Sony Movie Maker as the editor to create the videos we then upload to YouTube.
This concludes our tour of the GWA classroom operations. We chose to do this to show other clubs how we use our equipment in our dedicated classroom. This has been an evolution of about 6 years as we learned about what works and what doesn't. Hopefully this will help others benefit from our learning, and thank you for watching.